right, so this is some more AP review. I received a request to go over the 2010 BC Free Response 1. Specifically, I received a request to go over Part C, which is required to do Part D, but I figured we might as well bust the whole thing out anyway. So, essentially, this is one of the classic volume in, volume out, or rate in, rate out problems. So, I'm not going to read the entire problem. You're welcome to look it up on the interwebs. Again, this is 2010 BC Free Response 1. So essentially, G of t is the rate at which someone, maybe her name's Gina or some other name that starts with a G, is shoveling snow. So it's a rate that the snow is being removed. And f of t is the rate at which snow is falling. So f of t is an equation, and this is a calculator problem, so we'll be putting this in our calculator. So f of t is the rate the snow is falling or accumulating, starting at t equals 0, and g of t is the rate at which the snow is being removed by Gina or whatever name starts with a G, or Georgia or Georgina, I don't know, starts with a G. Okay, so notice that g of t is a piecewise function and that f of t is something we're going to use in our calculator. So this is a classic combination of rate in, rate out, and also making you do some work by hand and some on the calculator. So let's start with A. So A asks us how much snow has accumulated at 6 a.m. So a couple things to notice. The first thing is that snow accumulating has nothing to do with how fast Gina is shoveling. So G of t is irrelevant for part A. Part A is just essentially asking us to integrate the rate at which the snow is incoming, the snow is falling. Also worth noting is that Gina actually didn't start shoveling until 6 a.m. anyway, because the problem starts at midnight, t is 0, so 6 a.m. is when she starts shoveling anyway. But so for A, right, so for our part A, we want to integrate from 0 to 6 of f of t dt. We don't have to write what f of t dt is because, sorry, that extra dot isn't necessary, because it's given to us with the notation f of t, so we're allowed to use the notation we're given and regurgitate it back. So I'm allowed to just write this, and then honestly, I'm allowed to just type it in my calculator and write my approximate answer, which is 142.274, or 5, depending on if you round or truncate, cubic feet. Right, so I'm going to do feet cubed. Now, when you put this in your calculator, just to be clear, what I would suggest you do is I would suggest that you put in this f of t that they give you as your y1 in terms of x, not t. So my y1 would have been 7x e to the cosine of x. Obviously, you're in radian mode as always. And then I would do the classic math 9, which is function integrate y1 with respect to x from 0 to 6, and that's how I'd type this in and get this value. Remember, the AP is only checking for the actual correct integrand and the typed value with units. All right, part B is the first one that's going to ask us to do something involving g of t. So part B asks for the rate of change of the snow at 8 a.m. So the rate of change, right, so the rate of change of the amount of snow, right, is essentially going to be the snow coming in, which is f of t, so that's the rate in, right, the rate in, minus the rate at which it's being removed, the rate out. So rate in minus rate out, meaning that if I want the rate of snow, the rate of change of the amount of snow at 8 a.m., essentially what I want, so if we say at 8 a.m., I want f of 8, which I can plug in my calculator to find, right, minus g of 8, which I can look at the piecewise function and realize that 8 falls between 7 and 9, so g of 8 is a 108. So essentially, I'm going to use my calculator to find what 56 e to the cosine of 8 is, right? You don't have to write that out. You can just say f of 8 minus g of 8, but that's obviously a calculator problem. Minus 108, which I got from using the piecewise function, and when I do that, I'm going to get a negative 59.582, or 3, and because it's the rate of change of the amount of snow, it would be feet cubed per hour. Double check your units. You always want to make sure you have your units. All right, so now we get to part C, which is the part that I was actually asked to do, and then part D depends on part C, so we're going to erase and give ourselves some room. So part C doesn't need f of t at all. It only needs g of t. So in part C, what they want us to do, we know that the amount of snow would be the integral of the rate of change of the snow, so the amount that she has shoveled. So what they want in C is they want us to find h of t, right, which is the amount that, I'm just going to call her G because I don't know her name, I think it was Gina, has shoveled, right? in T hours since midnight, right? And so what that's going to involve doing, right, that's going to involve integrating our piecewise function. So the thing about integrating a piecewise function is that essentially you just integrate the pieces, right? So if I were to integrate my g of t dt, right, what's going to happen is I'm going to get that this integrates to some arbitrary constant, right? Because 0 would just integrate to arbitrary constant, which I'm going to call c sub 1 on the window from 0 to 6. Now, I prefer parenthetical notation, so that's what I'm going to use. You can obviously use the same window that they used. When I integrate 125, I'm going to get a 125 t plus some c sub 2, right? And I'm going to go ahead and say that that is from bracket 6, which would include the 6 to 7 parentheses. And when I integrate the 108, I'm going to get a 108t plus some c sub 3. Now, this isn't the exact way that the AP Solutions Guideline did it, but hey, I'm here because you might want to use something other than just the solution, so that's fine. So that's what I get, but now the trick is that I need a way to find my c sub 1, c sub 2, and c sub 3, right? Like that's the wild card here. So there's some information that I know. The first piece of information I know is that at 6 a.m., she starts shoveling. So G starts shoveling. She was asleep or she was having her coffee or whatever she was doing, but she wasn't shoveling until 6 a.m., which means that this constant, this amount of snow that she shoveled in this first window from 0 to 6 has to be nothing because she didn't start shoveling. Her rate was 0. She didn't magically shovel in her sleep overnight without doing anything, so that c sub 1 has to be 0. So again, I'm able to figure that the c sub 1, fine. But then here's the next wild card. This has to be a continuous function because whatever she did in this piece of the function has to naturally lead into when she started shoveling. It's not like she just blinked her eyes at 6 a.m. and magically shoveled 8,000 cubic feet of snow. That doesn't make sense. So what has to happen is that this piecewise function can't have any jumps. So whatever this function's value is at 6, even though 6 is not included in this window, must be the same value that this function has at 6. Because, again, not included in the window. So essentially what I realize is that at t equals 6, the left-hand side of this thing, which would be what would happen if I plugged into the first equation, is 0. The right-hand side must also be 0. So 125 times 6 plus c sub 2 has to be 0. Essentially, I'm going to get a 6 times a 125 with a negative in front as my c sub 2. So what you'll notice is what the AP has is instead of bothering to clean that up because maybe they're a little bit smarter than I am, they noticed that they could factor out a GCF of 125 and make this a 125 times a t minus 6 as their function. So that would be my middle function, right? And that's fine. I don't think I did. I think that when I did this on my own paper, I bothered to distribute the 6 times the 125. But this is the answer the AP gets for the middle function. But then the next mental leap that you have to make is that just like I couldn't magically have shoveled in my sleep momentarily between 6 a.m. and still 6 a.m., this amount of shoveling can't change. From 7 to 7, even though this is a parenthesis and this is a bracket, I can't just magically shovel more. So whatever value I get when I plug in at t equals 7 into the left-hand side, which would be, the left-hand side would be this function that I now know to be a 125 times t minus 6, right? It has to equal whatever the right-hand side is, which is a 108 times a t plus this c sub 3. So when I plug in 7, right, if I plug in t equals 7, I get 125 times 1, which is a $1.25. On the other side, if I plug in t is 7, I get a 108 times 7 plus a c sub 3. So I think I end up getting a 125 minus whatever a 108 times 7 is, plus a c sub 3. So, equals a c sub 3, I apologize. So if we clean that up a little bit, and I realize that it's gotten a little bit ugly and messy, but if we clean that up a little bit, what I notice is that when I plug that in up here, I can sort of cheat and do the same thing that the AP does in their answer key, which is notice that you can take out that GCF of 108 and then just leave the plus 125 chillin'. So what the AP has as their answer is a 108 times the quantity t minus 7 plus a 125, and that's the third part of their function. So if we bother to clean up our piecewise function now, And again, you don't have to do it that way. You can certainly distribute the numbers, and that's just fine, but this is where the AP gets their stuff from. So if up here we're just going to erase this for a sec, and we're going to copy what our final piecewise function should look like. My h of t, right, the thing that I get when I integrate this, should look like a 0 from 0 to 6. And again, I use the parenthetical notation. You certainly don't have to. And then the AP got this 125 times the quantity t minus 6, 125 times the quantity t minus 6, and that would be from the window for 6 with a bracket to 7 with a parenthesis, right? And then lastly, this 108 times the quantity t minus 7 plus the 125, and again, that would be from the bracket 7 to the 9 with another bracket. So that's how they got their answer to part C for the AP. Now, when we get to part D, so we'll erase all of this work and talk about our part D. When we get to part D, we're asked to find the amount of snow that's actually existing on the driveway at 9 a.m. So if you want to find the amount of snow, right, if we want to find the amount, not the rate, but the amount of snow at 9 a.m., that's going to involve taking the total amount in by 9 a.m. minus the amount out by 9 a.m., right? The total amount out. So we now know how to find the total amount out because h of t is the total amount we're looking at, so we know how to find that at 9 a.m. So total amount in is going to be the integral of my f of t, the rate that snow is falling from 0 to 9, which again I'm going to lean on my calculator to do, right? I'm going to have my calculator do that since I've already stored my f of t as my y1, that's fairly easy, minus, and then the amount out should be whatever I called h of 9, right? So I can find h of 9 by plugging in. So essentially, I can either straight up type this in my calculator as it is. This is what the AP needs to see. If you wanted to type in this integral minus and then type in what happens when you plug in a 9, that's fine. If you'd rather find that this is a minus 108 times a 2 plus a 125, and then combine that to whatever you get using your calculator, that's also totally fine. Either way, when you're done, you get a 26.334 or 5, depending on if you round or truncate, feet cubed because it's an amount of snow. So what the AP needs to see is this work and then this answer. If you choose to do some of the work by hand, that's on you.